polynomials using grouping. Okay, so this is yet another method. Okay, so Royce, what was our, so before we go on to our new method of factoring, what was the very first method we learned, which you had to do before you even start factoring if you can? Royce?
Greatest common factor.
That's right. So let me review a little bit. First, remember, before you do any factoring, you should always look for GCF. You guys remember that? Greatest common factor. That makes it so much easier to factor polynomials. And of course, after you do GCF, are you done? No. Okay, and even if you don't have GCF, what do you do next? What's another method that we learned so far? This one was sort of easy because it only had two terms. Yes? Difference of squares is exactly right. This one was sort of easy to identify, wasn't it? It looked like a squared minus b squared. You guys remember that? Right? And we know how to factor this. It becomes a plus b times a minus b. Right? What was the third method that we learned? This method, we took a long time doing it because we took some special cases. Yes?
Square the binomials?
That was a special case for this method of factoring. Squares of binomial is a special case. This is the general case of factoring any trinomial. You guys remember? What does any trinomial look like? Yeah. Is it x squared plus... Say it again? No. Michael? ax plus, yeah, ax squared plus bx plus c. This is the general case, right? Any trinomial will look like this, right? With some abc. Does the a have to be 1 every time for this one? No. See, remember we started with that, but then we learned how to do this. Remember how to factor this thing. You look for, when you multiply vertically, right? You look for the first and the last term, and then when you do the diagonals, right? That's how you get the middle term. You guys remember that? So that's basically, this is all we've been learning so far. So we're going to just do a very simple one. Example 1a, 5x plus wx. Right now, we're not factoring by grouping yet, but we're going to do these first, and then I'll show you how to do factor by grouping. So, but this is a warm-up sort of problem. Done this before. How do we factor 5x plus wx? Dana? GCF. Everybody, what's GCF of this polynomial? X. So, Eric, tell me what to write. X times what gives you 5x plus wx?
Is it x parentheses 5 plus w?
Exactly. Right? Isn't that how you factor? You factor out your GCF. This is very simple, right? Now, of course, you need to check inside. Does this factor 5 plus w? No. So you're done. Okay. Now, let me make it a little bit more interesting. Instead of 5x plus wx, look what I have. 5 times, in parentheses, x plus y, plus w times, in parentheses, x plus y. Is this any different than the one above? Yeah, kind of, but what's the difference here, Carolyn?
There's like a y.
No, that's not what I want you to see. How is this one different than the one above? They're basically replacing x with class what? X plus y. They're just replacing x with a... This is just substitution. Carolyn, how do we factor this? What's your GCF?
X plus y.
Exactly. It was x before. Now, instead of x, we have x plus y in both of the terms. Tell me what to write.
X plus y, and in parentheses 5 plus w.
Yeah, you see the game that you guys are used to this, right? They use substitution. Instead of x, they like to plug in some binomials or trinomials, whatever they want. But, you know, it's the same idea. Okay. Any question? Eric, question? Okay, do you see how it's factored? Look at the polynomial we had up here. Right, this is sum, isn't it? Now we have it as a product. Does that make sense? Do you see how it factors this way? May I move on? Alright. Let's take a look at this one now. What if I have 5 times, in parentheses, a plus b plus c plus w times a plus b plus c? Okay, how is this one similar to the ones that we had before? One person see it? Okay. Jason?
The GCF is a plus b plus c.
Yeah, instead of GCF being x plus y this time, it's just a trinomial a plus b plus c. Right? Do you guys see the idea? So how would you factor this out now? Yes.
A plus B plus C times 5 plus A.
That's 5. Okay. 5 plus W, you mean?
Sure.
Yeah, 5 plus. Yeah. Any question? This is pretty easy. We haven't done any factor by grouping yet, but I want you to get this idea because you'll see why you need to be able to do something like this, okay? Any questions so far? All right, and we need to talk about one more thing before we talk about factor by grouping. So, give me a sec. So write this down. When factoring, it is helpful to recognize factors that are opposite of each other. So we're getting you prepared to factor things using grouping. So this is important. When factoring, it is helpful to recognize factors that are opposite of each other. Okay. So what do I mean by this? I'll give you. Oh wait, write this down first. So anybody guess what I'm talking about here? Well, don't guess yet. Okay, let me tell you. First of all, what is opposite of 3, guys?
-3.
Okay, that's pretty easy, right? -3. How do you get opposite of a number, basically? How do we get opposite of 3? Tajwar?
Change the sign.
Change the sign, yeah. Okay, you could think about it that way. What's another way of thinking about it? Yes?
Multiplying by
Yeah, multiplying by -1. That's sort of a better way of thinking about it, algebraically, right? When you write the opposite of a number, you multiply that number by -1, it will get you the negative of that number. So if this is true, what do you think? For numbers, it's easy. What about for a binomial like x plus y? What do you think opposite of x plus y is? Yes, sir? Negative x and negative y? No. X plus y is a binomial. Negative x and negative y is not a binomial. What would be the opposite of x plus y? Spencer? Negative x minus y will be right because you'll be multiplying x plus y with -1. Don't you get negative x minus negative y? Tell me, does that make sense? It's not negative x and negative y, is it? I know what you mean, but you gotta say it correctly. All right, so if this is true, let me give you another one. What about x minus y? What's opposite of x minus y? Yes, sir?
Is it x plus y?
No, it would not be x plus y. Be careful. Eric, we just said that to get an opposite of some number, or in this case, polynomial, you need to multiply this polynomial by -1, right?
Okay.
So can you want to fix your answer?
Negative x plus y.
Negative x plus y. Please be careful. Wouldn't it be negative x plus y? Yes? Yes, sir.
When do you get the same answer?
What do you mean? Oh, x minus y is not, I mean, x plus y is not opposite of,
Wait, no.
yeah, be careful, right? You gotta multiply that -1 to both of these terms because there are two terms, right? If you just write x plus y, then you would only be multiplying -1 to the y. Alright, so you see? And look what it says up there. When factoring, it's helpful to recognize factors that are opposite of each other. So if I said, let's look at the last one. If I ask you negative x plus y, would you be able to tell that's the opposite of x minus y? How would you be able to identify? If I give you negative x, negative y, would you know that that's the opposite of x plus y? How would you identify these things? Because I just said it's important, or it's helpful to recognize opposite of these factors. I mean, opposite of these polynomials. Well, let me ask you this. Is this true? Is x minus y opposite of y minus x? I mean,
Yeah.
people, I want you to discuss with your group. Go ahead, everybody think about this. That's a question. Is x plus x minus y, is it opposite of y minus x? Go ahead, everybody think about it. Go ahead, talk to your group. How many people say yes? Raise your hand. How many people say no, they're not? This is subtraction. It looks like they're doing the commutative subtraction. It's not true, right? How many people say no? So I'm asking whether or not they're, I'm not asking whether or not they're equivalent. I'm saying is one opposite of the other. That's all I'm asking. Okay, so I think that's what a lot of people are saying. Yeah. So I'm not asking whether or not we could. What I'm saying is, in other words, if I were to multiply -1 to x minus y, would I get y minus x? That's my question. What's the answer?
Wait.
If I were to, because that's how you get the opposite of a number or polynomial, right? If you were to multiply -1 to x minus y, would it be same as y minus x? The answer is yes. I mean, someone will say, wait a minute, wasn't it -y plus? Look what we have up here. Didn't we do this? We already said opposite of x minus y was -x plus y. How do we get y minus x? Chuck?
Change their order.
Yeah. What does y, I mean, what is x plus y same as? Isn't this addition? Let's use the community property of addition. I could rewrite this as what? Y plus? How could I rewrite?
Negative x.
Yeah. How can I rewrite y minus x as an addition? Y plus
Negative x.
x. Can I do that? Does that make sense? What makes it sort of confusing to see whether or not they're opposite of each other? The order, isn't that right? So guess what? If you ever have this kind of problem, and if you want to see whether or not you have the opposite of the number or not, isn't it best to write it as, what kind of form is this? Where you write x first, then y. Standard form. That's the key, guys. So if you ever get confused, rewrite things in standard form. Isn't this a lot easier to see? If I ask you this, you would have said, oh, of course, that's true, right? If I ask you, is x minus y opposite of -x plus y? You would say, of course it is. Because what's the opposite of x?
Negative x.
Negative x. What's the opposite of, well, this is plus negative y. What's plus opposite of negative y?
Plus y.
Positive y, right? Isn't that easier to see? When I switch the thing order around, it could get kind of confusing. So, key is, write this down.
Oh, we can see it.
I'm sorry. Here. Can you see this now? Okay. It is important to be able to identify factors that are opposite of each other. And the key is to write things in which form?
Standard form.
Standard form. And you will see, you just have to know that, look at each of the term, it's just opposite of the other. Does that make sense? Okay, so that's how you do that one, okay? Yes?
What does it say after the two?
To be able to identify. Identify. So you need to write things in standard form, guys. That's going to be really helpful, okay? So is this okay? Does this make sense? And you'll see why. You may say, what, why are we doing all this? Okay, fine. So let's look at this now. Take a look at this example too. Why did we go through all these four? Well, because when I have something like this, 5 times in parentheses b minus 4 plus 3b times in parentheses 4 minus b, something like this, it's going to be really helpful. Okay, so first of all, if I ask you to factor this problem, will you be able to factor this right now?
Yeah.
Really? Do you see any GCF? I don't see any common factor.
Wait, yes.
You do? What's a common factor?
No.
Anybody? I mean, they look similar, right? I got B here, I got B here, I got 4 here, 4 here. But they're not the same thing, are they?
Different
Yeah.
sign.
What'd you say, Chuck?
The opposite.
They're opposite. Is exactly right. Chuck, you get the go get the medal. That's the main. That's very good. All right. You get to wear the medal. Really? Oh, Jason, really?
Yeah.
I'm sorry. Yeah, I should have. I'll look for that next time. All right. So what is Chuck saying? Let's see whether we can understand what he's saying here. First of all, Chuck said, oh, they're opposite of each other. Well, how do we know? It doesn't look like they're opposite. Well, what I just told you, rewrite things in standard form. And do I like subtraction?
No.
No, okay, right. Rewrite things in addition and then write it in standard form. There it is. Okay? Well, I didn't write this in addition, but you get the idea. And look, I have positive b over here. I have what? Negative b. I have, this is plus negative 4. So this is negative 4. What do I have here? Positive 4. Aren't they opposite of each other? So what can I do so that I could actually see these one with a common factor? What's the idea? Dana? You can't multiply by -1. I know what you mean by that, but you gotta say that carefully. What do you mean by multiply by -1? Is there a way to rewrite negative b plus 4 so that it looks like b minus 4 somehow? Turns out you could rewrite this b minus 4 as negative 1 times what? How can I write negative b plus 4 as negative 1 times what? Is there a way to rewrite negative b plus 4 as negative 1 times something? Yes, Livy?
Negative 1 times b minus 4.
That's right. Couldn't I do that? Isn't negative b plus 4 same as negative 1 times b minus 4? Right, guys? If you don't believe me, how could you check? Multiply it out. What's negative 1 times b? Negative b. What's negative 1 times this is plus negative 4? What's negative 1 times negative 4? 4. Isn't that what we had before? Right, guys? So what have I done here when I rewrote this as b minus 4 as negative 1 times b minus 4? Am I multiplying negative b plus 4 by negative 1? No, that's not what I'm doing. What am I doing here? I'm factoring out a negative 1. Am I not? Look. Do you see how I did factor out negative 1 from it? Because wasn't negative 1 a common factor here of negative b? Wasn't negative 1 a common factor of 4? Because what's 4? Negative 1 times? No, 4 is not negative 1 times 4.
Negative 1 times negative.
Negative 1 times negative 4 is 4. Isn't that right? So I could factor out a negative 1. Does this make sense? Some of you are having trouble. Go ahead, talk to your group. See if that makes sense to you. Everybody help each other out. So, how many people understand what's really going on here? Am I multiplying negative b plus 4 by negative 1, or am I just factoring out a negative 1? I'm factoring out. You can't just multiply a number by negative 1 all of a sudden. You can't do that, right? If you have 3, can you just multiply 3 by negative 1 and go, oh, now I have negative 3? No, you can't do that. But I could factor out a negative 1. If I had 3, I could write, oh, it's negative 1 times negative 3. That's the idea here. I have negative b plus 4. I'm just saying, oh, I could rewrite this as negative 1 times b minus 4 because I recognize, just like Chuck did, negative 4 plus b is opposite of b minus 4. Right? Why did I do all this work for? What's the whole point of this? Jason? Now I know I have GCF. Isn't that right? But Tajwar, before I do, always simplify, right? What is 3b times negative 1?
Negative 3.
Yeah, that's what you're telling me to do, right? So rewrite that. Always simplify first. And now you see that GCF is b minus 4. Do you see that, guys? Yes? So now, Claire, how should I rewrite this now? Now that I see my GCF, because in the very beginning, did you know that I had a GCF of b minus 4? No. But now that we see it, because we did all this work, right, we recognize that 4 minus b was opposite of b minus 4, right? So now I see the GCF clearly. How do I factor out this GCF?
You do b minus 4 in parentheses times 5 minus 3b.
Exactly right. Do you guys get this? Do you see my answer? Do you see how I was able to factor now? You see? So, unlike example 1, you many times, like you're on your homework tonight, they're not going to just let you see the GCF right away like that, right? You're going to have to do some work, okay? It'll be like the opposite of what's in there, right? Yes?
Could you just do 5 minus 3b?
Yeah, that's what I have right here. On the second. Yeah, on the second one. Yes?
But in the beginning of the problem, couldn't you do it the other way, like negative 5 times, like change the other one?
Oh yeah, but then isn't it easier to keep things
I know,
positive?
I'm just asking.
Yeah. So you could have changed this negative 5 times negative b plus 4 or something.
Yeah.
You get that negative 1 to
Yeah.
5. But yeah, you want to write things in standard form first of all,
Yeah.
and you want the first term to be positive as much as you can. It's easier that way. You see what I mean? All right. Let's do a couple more so that you get more used to this. May I move on to example 3? Let's look at example 3 now. Here it is. 3y in parentheses times y minus 3 minus 2 times in parentheses 3 minus y. Right now, I don't see any GCF because they don't look the same, right? But guess what I'm going to do first? Yes.
You're going to take out a negative 1.
I'm going to take out factor out a negative 1. But before I do that, I'm going to write things in standard form using addition. Is that okay? Go ahead. Why don't you all try this then? I'll wait. So it's very similar to the one we just did, okay? See if you can do it yourself. And the kind of work I'm expecting is just like example 2, right? I want to see all that work where you write things in addition, write things in standard form. You could do that in one step. and then how you factor out a negative 1 from there. Yes? I want to see all that work. Okay, go ahead, everybody try. Here we go. So let's write this in addition and as standard form, as a standard form. Who could help me how to do this here? Mimi?
3 y, oh,
Yeah.
3y, parentheses, y
Mhm.
minus 3
Uh-huh.
plus negative 2, and then negative 1, and then 3 minus
Oh. What about, let's rewrite 3. I wrote it this way,
1. Oh,
in
negative
standard
2
form,
plus 1.
which is negative y plus 3, isn't that right?
Yeah.
All I did was rewrote 3 minus y. That's not in standard form. Remember I told you the key step is to write things in standard form so you could see that you have a common factor. Otherwise they don't look common, right? They look very different. Okay, then, okay, of course I changed this to addition. Then I'm going to factor out a negative 1 from y minus 3. Kevin, can you help me how to do that?
You would put 3y
Mhm.
times y minus 3.
Right.
Plus negative 2 times negative 1 times 3 minus y. I mean y minus 3.
Y minus 3, right? Now, once you've done this, once you factor out that negative 1, do you guys see a common factor? Yeah, but you need to listen to what Tajwa is saying. Always simplify. What is negative 2 times negative 1? 2. So we write it this way. Then you see your GCF, right? Does that make sense? So once you factor out a negative 1, multiply with that coefficient if there is 1. If there isn't, there's 1 anyway, right? That invisible 1. All right, so now, what do we do next here? Who could help me? Okay, many of you. How about Angel?
Y minus 3 in parentheses,
Mhm.
minus 3y plus 2.
Exactly. How many people got this answer? Raise your hand. Do you see the kind of game that they're playing? Yeah. Okay, so you have to be able to identify the factors that are opposite of each other. And why do you think it's important to notice that factors that are opposite of each other? Because if you factor out a negative 1, what can you see? That is going to be your GCF. Does that make sense? So they're trying to sort of hiding that GCF by multiplying that by negative 1, kind of. They're giving you the opposite of the GCF. Now we know how to deal with those. You rewrite them in standard form and factor out a negative 1, and you will be able to see your GCF. Okay? All right, may I move on to next one? So far, we haven't really actually done grouping yet, but you see why we're doing all this, okay? We'll get there. Basically, let me just tell you a little ahead of it. We're going to try to make polynomials that look something like this, like right here, where you have a greatest common factor. That's what we're trying to get to. What they do is they don't give it to you like that in the very beginning. They're going to give you something a little bit different. Anyway, we'll get there in a minute. All right, so next, example 4. Here we go. Okay, try example 4. Everybody go ahead and try. It says 5 times, in parentheses, a minus 3 minus 2a times 3 plus a, in parentheses. All right? Okay, go ahead, everybody try. I'll wait. All right, this one's kind of different, isn't it?
Yeah.
How many people were able to figure out your GCF on this one? Yeah, good. Because there isn't any GCF. Yeah. Because yeah, they're not opposites. Exactly right. Chuck is right. Look, I have positive A here. What do I have here? Positive A. Right there, you should know that they're not opposites. You have negative 3 here. You got positive 3. Look, even if I write them in standard form, right, guys? Are they opposite of each other?
No.
And are they common factors? No, they're not. So what are you gonna do? You don't have it. Well, not quite yet. Yeah, even if I factor out a negative 1, I get negative 8 here, right? Do you see what I mean? So you don't have GCF. Well, doesn't mean you stop here. When you get something like this, the only way for you to factor this is if you simplify the whole thing. Does that make sense? So just because you have no GCF doesn't, it may be that it could be factorable. So you basically distribute 5 and distribute 2a to this binomial. Even if you do that, like it's not factorable. But you have to simplify. Once there is no GCF, even if you do this, you gotta simplify and get a trinomial, and this trinomial becomes negative 2a squared minus a minus 15. So I factor out a negative 1 because remember I don't want that first term to be negative. And remember we talked about how it's easiest if you write negative 1 times that trinomial. Then the first term is not negative anymore. And even if you could try many different ways, it doesn't factor. Okay, so anyway, but when you don't get GCF, that means you gotta simplify and write it into a trinomial. Is that okay? All right, so I'll wait. So be careful. Are you going to always get a GCF when you do this problem? No, it may not. You may not be able to get GCF sometimes, even if right, because things may not be opposite of each other. Yeah, Jason. Okay. Oh, so it's not factorable. So what do we write as the answer? We say prime what? Polynomial, right? So you should write the answer is prime polynomial. That's your answer. For what we said we're going to do in the very beginning, we're going to be factoring by grouping. We're going to group them by 2's. So if I have something like this, and you will see why we went over all these examples before. I have 2ab minus 6ac plus 3b minus 9c. Okay, if you have something like this, if you have 4 terms like this, first thing I would like you to try is group them by 2's. What do you think I mean by group them by 2's? Yes, Dana? Kind of. I first of all change everything to addition, okay? Right? Because I don't like subtraction. And then you group 2 terms at a time by using parentheses. So here. So this is why it's called factor by grouping. Okay? Do you see how I'm grouping 2's? Grouping them by 2's? If I do this, there's a reason why I did this. Because when I did that, first of all, was there any GCF in the beginning? No, right? Oops. On the wrong one. Give me a sec, sorry. Here we go. So was there any GCF here? No. So you couldn't do much. So when that happens, you group them by 2's. Now, if you look at 2 at a time, do you have a GCF for the first 2 terms?
Yeah.
Do you have GCF for the second 2 terms?
Mm-hmm.
Then if you do, you factor those out, and you hope that you will get a greatest common factor from both of these. Does that make sense? I'll show you what I mean by that. So after we factor out our GCF, here, what is our GCF of 2ab plus negative 6ac? Yes? 2a. What is the GCF of 3b plus negative 9c? Yes? There is. 3b plus negative 9c, there is the greatest common factor. Say it again? 3. And we did that hoping that you will see then a greatest common factor. Do you see what I mean? Because at this point, just by factoring out a 2a and 3, you only factor partially, right? You only factor these first 2 terms and the last 2 terms. You haven't factored the whole polynomials yet. But the reason why we're doing this is so that we could hopefully see that there is going to be a GCF from, right, both of these groups. And there is. Isn't that nice? What is our GCF? B plus negative 3c. You see how that works out? You see why we're grouping them by 2's? After doing this, you will see that so this is how they sort of hide their GCF. Does that make sense? Right? And now this becomes the sort of problems that we did previously from example 1 through 4. Do you see what I mean? Doesn't it? Right? You see how it just becomes, right, the same problem as example 1 through 4? That's why we did all these examples 1 through 4. And this is another way of them hiding the GCF. Does that make sense? So, what do we do next here? 2 people know? Oh, okay. Eric?
You do the 2a plus 3
Mm-hmm.
and parentheses b plus negative 3c.
Yeah, I like to write the GCF first. So can I write the GCF b minus 3c first? Then write 2a plus 3? Because then I could kind of in my head sort of distribute it back and then check and see this is what I had before. But it doesn't really matter, right? Do you guys see the idea? So this is sort of the thing that they do. So that's why we did all these examples before, so that we could do something like this. You see what I mean? Yes, Dana?
So if there's
Yeah.
could you group it by
3's? Yeah, it could be. Yeah, if there were 6 of them, you should group them by 3's to start with. But anyway, yeah. All right, let's try one more. Actually, there are 2 more. Let's try next one. All right, then try this one yourself. You should all be able to do this problem without much problem. AB minus 2AB plus 2AC minus 2C. And guys, I'm telling you, it's always nice to change everything to addition. Okay? All right, so please change everything to addition and then factor by grouping, okay? This is called factor by grouping. You're going to group them by 2's, right? Go ahead, everybody try. I'll wait. All right, so how many people wrote this as this way? AB plus negative 2B with the whole thing parentheses there with that first two terms, plus AC plus negative 2C. And as you can see, the first two terms have GCF of B, second two terms have GCF of C, and you can factor those out. And now, do you see your GCF? Your GCF is A minus 2. So how many people got A minus 2 times B plus C? Very good. Now, let me give you the last one, because this is the one where they get sort of tricky. Watch this. Here, this one, I'm going to put a star on this one. This, and you will see why I'm telling you to rewrite things in addition. Because some of you say, wait a minute, why do you have to write everything in addition? Try this one here. I'll wait. It says 3hk minus 2k minus 12h plus 8. Guys, I'm telling you to rewrite things in addition first. Okay, did you all hear me? Okay, please do that. Okay, everybody try. So this one looks like the ones that we did before. So first step, rewrite them into addition. Who could tell me how to do this first? Cool?
3hk
Uh-huh.
plus negative 2k
Right?
times
Times? Let's rewrite them as addition. 3hk plus negative 2k plus
negative 12.
negative 12h plus 8. Did you all do this? Okay, guys, that's the key step. Then, we're going to group them by 2's, right? Right? Group the first two and then the last two. So let's group them. Okay, hold on. Guys, whenever you group them by 2's, you want addition in the middle. You don't want subtraction in the middle. Because if you have subtraction in the middle, it's going to get sort of, you could get silly mistakes real fast, okay? That's why I want you to change everything to addition. Does that make sense? So when you group them by 2's, please make sure you have additions in between these, okay? All right, what is my GCF? Here. The first two terms? Yes. Two people see it? That's it? 3hk plus negative 2k. What's your GCF? Yes. K. So you factor out a k, right? Isn't that the only GCF you have? So it's going to be k times 3h plus negative 2, yes? Plus, what is my GCF for negative 12h plus 8? By the way, we're hoping that you're going to get a common factor here, right? So don't you want the first number to be positive? So what should we factor out? Yes?
4.
If I factor out a 4, I could do that. 4 is GCF. But look, if I factor out a 4, is there any chance that I'm going to get 3h plus negative 2 as my GCF? Really? Because then it's going to be negative. Let's factor out a negative 4. Isn't that easier? When I factor out a negative 4, what do I get, class? Do you see my reasoning behind it?
Yes.
Why do I want to factor out a negative 4 instead of 4? Well, because I want the next number to be positive, right? I want that to be positive. So what do I get? Do I get what we want here? Is that what we need? 3k plus negative 2? Do you see how I did that? Yeah, I could have factored out a 4 and then factored out a negative 1 again, right? But why not just do it in one step? Because I knew I wanted the number, right, after I factor out the number, to be positive, right? For there to be any chance to get a greatest common factor. Do you see what I'm doing? But could you have factored out a 4 and then a negative 1? Would you get the same sort of binomial? Then what do I factor? What's my GCF, James?
3h minus 2.
Yeah, 3h minus 2. Everybody, how many people got this so far? Okay, if you didn't, do you see what we're doing here so far? Okay, now James, tell me what the answer is.
3h minus 2 parentheses k minus 4.
Exactly. How many people got this answer? Raise your hand. We good? Can you do something like this for your homework tonight? Okay, so if you have 4 of these terms, first change it to addition, right? Then you group them by 2's, hoping that you find a greatest common factor. Does that make sense? All right, good.